Welcome to this presentation. This video is all about Earth eclipse of satellite, Sun satellite range and sub-satellite point and so on. If the Earth's equatorial plane coincided with the plane of the Earth's orbit around the Sun, then the geostationary orbit satellites would be eclipsed by the Earth once each day. As it is, the equatorial plane is tilted at an angle of 23.4 degree to the ecliptic plane, and this keeps the satellite in full view of the Sun for most of the days of the year, as you can see in this diagram. Okay, so in around the spring and autumn equinoxes, when the Sun is crossing the equator, the satellite does pass into the Earth's shadow at certain periods, and these being periods of eclipse. And the spring equinox is the first day of the spring, and the autumn equinox is the first day of the autumn. Eclipses begin 23 days before equinox and they end 23 days after equinox. The eclipse lasts about 10 minutes at the beginning and the end of the eclipse period, and increases to a maximum duration of about 72 minutes at a full eclipse. During an eclipse, the solar cells do not function and operating power must be supplied from the batteries. When the satellite longitude is east of the Earth station, the satellite enters eclipse during daylight hours for the Earth station. So this can be done shown in this diagram. This can be desirable if the satellite has to operate on reduced battery power. Where the satellite longitude is west of the Earth station, eclipse doesn't occur until the Earth station is in darkness and usage is likely to be low. Thus, satellite longitudes which are west rather than east of the Earth station are more desirable. For a geostationary satellite, the solar eclipse due to the Earth occurs during two periods that begin 23 days before equinox and ends 23 days after equinox. So we must be very careful in designing the orbit of the satellite so that the sun eclipse occurs. Whenever the sun eclipse occurs, we have to use the battery so that the satellite lifetime will be reduced. And next, let us have an insight of sub-satellite point. The point on the Earth vertically under the satellite is referred to as the sub-satellite point. The point at which the line between the satellite and the center of the Earth intersects the Earth's surface is called sub-satellite point. The latitude and longitude of the sub-satellite point and the height of the satellite above the sub-satellite point can be determined from the knowledge of the radius vector, or thus you can see the sub-satellite point. The point joining the satellite and the Earth radius, which intersects the Earth radius, is called sub-satellite point. So you can see in the figure the meridional plane which cuts the sub-satellite point in this figure, and the height of the terrain above the reference ellipsoid at the sub-satellite point is denoted by HSS, and the height of the satellite above this is known as small hss. Thus, the total height of the satellite above the reference ellipsoid is given by h is equal to capital HSS plus small hss. Next one is sun transit outage. Another event which must be allowed for during the equinoxes is the transit of the satellite between the Earth and Sun. When this happens, the Sun appears as an extremely noisy source which completely blocks out the signal from the satellite. This effect is termed as sun transit outage, and it lasts for short periods, each day for about 6 days around the equinoxes, and the occurrence and the duration of the sun transit outage depends on the latitude of the Earth station, a maximum outage time of 10 minutes being typical. So this diagram shows the sun transit outage where the satellite is placed in between the sun and the zone. Generally, sun outages occur in February, March, September and October. that is around the time of equinoxes. At these times, the apparent path of the sun across the sky takes it directly behind the line of sight and between the Earth station and a satellite. So, as the sun radiates strongly, the microwave frequencies used to communicate with the satellites, for example, C band or Ku band and Ka band, the sun swamps out the signal from the satellite. The effect of a sun outage can include the partial degradation, that is, an increase in the error rate or total destruction of the signal. And the transit of the satellite between the Earth and Sun occurs when the Sun comes within the beam width of the Earth station antenna. So, this effect is called a sun transit outage. As I mentioned earlier, there are a number of perturbing forces which causes an orbit to depart from the ideal Kepler orbit. For the geostationary case, the most important of these are the gravitational fields of Moon and Sun and the non-spherical shape of the Earth. So, you can say other significant forces are solar radiation pressure and reaction of the satellite itself to motor movement within the satellite. So, as a result, station keeping maneuvers must be carried out to maintain the satellite within the set limits of its nominal geostationary position. Thank you.